In this video, we will demonstrate how turbidity measurements are accomplished. We will also demonstrate how a new turbidity calibration curve can be entered if absolutely necessary. Using the built-in turbidity calibration, the probe can also be used to measure turbidity in NTU units, as shown here in a chlorine contact basin. No calibration is generally required with turbidity measurements. As a reminder, the instrument comes with a factory default calibration for turbidity that should be perfectly suitable for most applications and measurements. We turn the instrument on, and we first need to make sure that the measurement point that we are going to use is linked with the default calibration curve for turbidity. We do that by going into the menu and scrolling down to the choice of measurement point defined, or measurement point definition. We press enter and choose the sample ID or the measuring point we'd like to use. In this case, a convenient choice for most turbidity measurements around the plant is simply TURB, and confirm that it is associated with the curve for turbidity. So it's pointing to CTU, which is the default factory curve for turbidity, and we press enter. If we step back one level, we can scroll back up to the calibration screen, press enter, and we can see that the default calibration curve for turbidity consists of 3 points, 1, 2, and 3. We can see what the concentrations are of the 3 points in the curve by simply pressing enter. So the highest point was 2000 NTU in the factory calibration. The middle point was 400 FNU, and the first point is 0.006 FNU. So using this factory calibration curve, we will go and take measurements. We first choose the style or the measurement mode, and in this case we will use single and save. We'll press enter, and we then need to make sure that the measuring point that we've chosen is what we want. And in this case, we want to use turbidity because we know that's linked to the turbidity calibration curve. We'll drop down to measurement now and take the clean probe and place it into a simple beaker of water. To take the measurement, back on screen we will press the enter key, and I believe it will stay on for about 5 seconds before it locks in on a measurement. It's the on time that determines that. And in this case we have a measurement of 10.4 FNU. One point to make is this container that we're using in this video demonstration is great in that you can see the probe and you can see the sample, but it is not ideal for the best accuracy, especially in low-level measurements. The glass container will reflect light, and it really should be a black container. There's more information in the manual, but for the best measurement accuracy, you should place the sample in a container that is black and non-reflective, and it's big enough that the probe does not come within about 70 millimeters or about 2.7 inches from any of the walls of the container. We've chosen glass just for the purpose of demonstration in this case. If we wanted to calibrate the instrument, you would need to prepare or obtain some calibration solutions. In this case, we have acquired 3 different turbidity standards, and again, this is not necessarily necessary for most applications, but we'll demonstrate it just to show the purpose of a multi-point calibration. The 3 standards we're using are 20 NTU, 800 NTU, and 4000 NTU. To prepare the instrument, we'll exit out of the measurement we just took by pressing the clear. We'll stop the measurements from being taken place, and we'll scroll over to the menu mode and enter into calibration. We will choose curve turbidity, and as we scroll down before, there are the 3 calibration points upon which the factory calibration curve is built. To change them, we enter into a little bit of a strange sounding mode, but it's called memory. And memory simply refers to the fact that we are now going to memorize or take measurements and overwrite the memory of the calibration curve. We press enter and then simply choose the point that we want to take a measurement on. In this case, we'll choose 0.1 for our 20 NTU solution. We'll place the probe down into the 20 NTU standard, and back on the instrument, we'll press the enter key to take the measurement. Notice it says to wait and it says memory, so it's actually reading this particular solution. Once this has stabilized, we can continue on to 0.2 and 0.3. Okay, we'll then clean off the probe with a little bit of deionized water and move on to 0.2, the second standard, which in this case is 800 NTU. So we'll go to memory again, we'll scroll to 0.2 and take a reading of the second solution. Again, ideally if we were using true standards and performing a calibration for the best accuracy, they would be in a dark container and a little bit larger solution so that the probe was not in such close proximity to the glass beaker. Notice a star has now appeared on the 2 points that we have measured, and we'll now continue on to 0.3. So we'll go into the third solution, the 4000 NTU solution. And back on screen, we'll go back up to memory to take the measurement, press enter, scroll down to 0.3, and we will select it. So we're now taking the measurement on 0.3. The instrument is reading the scattered light reaching the variety of different detectors. In this case it's 90 degrees, so we're only taking a measurement at 90 degrees on the 2 different receptors. And notice our 3 points have stars because they have taken the measured of scattered light, but they have not been instructed the actual turbidity values. To do so, we'll scroll to 0.1, press enter, and we'll overwrite the factory value of 0.06 and scroll over and create this one to be 20 NTU. NTU. So that's the first point. Notice once it's entered, the star will eventually go away. When we scroll down to 0.2, notice the star has been updated, so it now knows the concentration. 0.2, we will go in and adjust to 800 NTU, which is the value of the standard we use for 0.2. And finally, we'll scroll down to 0.3 and update this to a value of 4000 NTU. It immediately takes those points and overwrites the default factory calibration. Any measuring points that are now connected to turbidity would use the updated turbidity calibration. If for any reason the instrument needed to be resorted back to the factory default calibration for turbidity, it can be accomplished as follows. We'll start in the main menu, enter the calibration mode, and we can simply drop down to the points within turbidity and see that they are at the values that we have changed them to. However, if we want to update this, we can enter the calibration mode again and then press enter to choose the variety of different curves, and then scroll down to the bottom where we have a choice to reset. This will reset the turbidity calibration curve. It will not overwrite the suspended solids curves. There's a different way of overwriting those. So we press reset, and that will resort the calibration curve for turbidity back to the factory default. To confirm or to verify, we can simply enter the calibration menu, make sure we're set to turbidity, and scroll down to 0.1. Notice it's back to the factory default of 0.006. This concludes the video on measuring turbidity and calibrating the TSS portable instrument.